Hey everyone, Radhe Radhe. My name is Ann Pasha. I'm the Cloud Native Developer Advocate, and today in this lecture we'll be taking another solution of the Gateway APIs, that is kgateway project by the Solo.io. It's been handled by the Solo.io's community. In the last lecture, we tried to explain about the Selenium's ingress as well as the egress gateway APIs, and continuing our playlist about the gateway APIs as well as ingress and various other networking projects and the cloud native stack particularly, and the development as well. So today we'll be learning about the kgateway project. We will be understanding about this architecture, how and why it was actually built, how is it different from the other gateway projects at the moment, and what are the particular things, and how is it managed, and is it an open source project or not, and what are some of the sites or some of the sources from where you can also learn about this particular project. uh, Gateway project, it is being handled by the Solo.io. It's a cncf Sandbox project, and also it's being managed by the cncf Open Source Foundation, Cloud Computing Foundation, and it's being given as an enterprise vendor. It has the enterprise vendor, which is Solo.io, and the data plane proxy of this particular project, the kgateway project, is the Envoy. It uses the Envoy as its data plane proxies. We'll also learn about the various the architecture of the whole gateway project of this key gateway project. It's really amazing. So it's been having the latest version. It's the v.2.0.1 at the moment, and we will try to understand about the basic understanding about the architecture of this project. So key gateway project, it first of all, let's try to understand about the component architecture of this project. You might be seeing a diagram at the moment of the key gateway project somewhere on the screen. So it has various features. It has various components of your gateway API. And the main function of this is that it works on the namespace project, and the namespace version, it's a bit different from the other gateway APIs. And in this thing, whenever a user usually push its request to your cluster, to your data plane at the moment, then that request will pass to the gateway proxy, depending upon the routing, the policies and all the traffic rules that has been set by the administrator at that moment, and then later it will pass through the the backend of your gateway API. So in that backend, we usually have various different components, which will start with the secret watcher, the configuration as well as the secret watchers of your architecture. It depends, and it usually monitors if there is any new gateway that has been adopted to your architecture at the moment, or any resource of the gateway project that has been updated or uploaded to your architecture or infrastructure at the moment. So it will be looking after and trying to monitor all those particular resources that has been pushed to your architecture, your infrastructure, and then if any change or any new resource has been found by your watchers, these particular watchers, then it will be forward to the the translation engine of your backend of our kgateway project. It's architecture. It's another resource, that is the translation engine. It usually helps in translating any any change or any as the resources of the gateway project, or the gateway API, Kubernetes gateway API that has been pushed to our architecture. All of those has been translated to the configurations, to the Envoy configurations in your architecture, in this whole process. And then later on, those Envoy configurations are being consolidated into an XDS snapshot. So many of you must be an engineer, and I'm like the cloud native engineer, so they must be a lot more experienced. But those who doesn't knows about the XDS snapshots, they might have confused it with the GitHub's whole version control thing. So it's not like that. The XDS snapshots usually helps you in managing and connecting your the traffic management of your architecture at the moment by the help of the Envoy proxies. So the X in this particular thing usually depends upon the various various different parts of your architecture, which will be monitoring which route you have to take, which will be monitoring which cluster it has been talking about, which IP or the DNS it has to translate with or forward the requests to, or the various resources and various other things as well, which usually at the end helps you in bringing up the better efficiency for your project, better smoothness to the traffic management as well. We'll also try to understand about the various different things, very different ways in which we can deploy this, the gateway API, the gateway sidecars, or gateway to our architecture, whether it is the the isolated one or the shared one or the central ingress gateway API. It's all been given under the official documentation of the kgateway project. Make sure to check it out as well. Alright, so it is usually the past whenever any change that has been caught by the secret as well as the configuration watcher, that is being passed to the translated engine, and then the translated engine helps you in converting those updates or the the Kubernetes gateway or the gateway resources that has been caught by the watchers are being translated or being converted back to the the envoy configurations, and then envoy configurations are the consolidated into an XDS snapshots, and then we have a reporter comparator. Whenever this change of the XDS snapshot has been completed, then the reporter helps in receiving this report from every resource that has been caught and then converted into the XDS snapshot, and then storing that particular information into the etcd server. Etcd server, this particular information has been stored into the etcd server, so that the further version controls or anything else can be done in a mutable format, in the immutable format, not in a mutable format, like the immutable format, which usually helps you in destroying the the older version which existed onto your architecture. That's all been done because the existing server, existing version, or the the architecture that is present or the resources of your cluster might be having some security vulnerabilities as well, whether it's about the cluster, the certs or the keys or various other things as well. And whenever this update has been adopted to your architecture, the older version is being killed, and then a newer one, replicated one, is being uploaded or deployed to your architecture. It helps in the security efficiency as well. How? There must be various authentication and the certs or the keys or various other things as well. They all have some expiry date as well. Other than just the CVs and all those stuff, there are various automated things as well, like the expiry dates or various other things as well. So those expiry dates are being updated as soon a new resource has or the replicator has been pushed to your architecture, and then in that way, the security has been, the efficiency has been increased. It has been enhanced in that format. So the etcd server, which will store the current the current state of your architecture at the moment of the XDS snapshots that has been sent by the envoy, the data proxy of this kgateway project, and then later on the the gateway project also has a kgateway XDS server. And kgateway XDS server is provided to the kgateway, like the kgateway pods, which will helps you in providing the XDS snapshots. It's the same. And then ahead of it, we usually have the gateway proxy as well, gateway proxy in the cluster, which helps in pulling the latest envoy configuration from the kgateway XDS servers. And then later on, it can helps you in like all the traffic that enters into your cluster, depending upon the routing policies as well as the traffic management rules that were being set up by the administrators. It will follow them all, and then later on the whole traffic flow will takes place according to the pre-decided format or the traffic management format, the policy that were being laid earlier. Kgateway proxy uses the listener and the route specific configurations that was provided in the XDS snapshot to perform the routing decisions and forward request to the destination in the cluster. That's the major definition that has been provided to you on the documentation page. You can also see that. Otherwise, the the gateway project as the gateway proxies, as you all knows, it will work on the pre-decided routing policies, and also will helps you in sending a request to the IP addresses. The user will send the request with the help of the IP addresses and the host name, and that will be the gateway proxy. So it will act as a kind of a gateway for the whole kgateway project, the backend which was being laid by the gateway API. So it was all about the architecture of our project. Other than that, we also has various different deployment patterns as well in the kgateway. For one of them is the simple ingress. Simple ingress will just has a simple gateway API that is being deployed onto your cluster, which will be handling various different services depending upon the various different policies that were being laid. And then we might also have a shared gateway, which, like, if I am having a smaller workload at the moment, so it won't be having as much traffic. So that's why I don't need to split the traffic depending upon the various different key factors on the labels or various different other factors as well. So we might use a single simple ingress gateway API instead of having a shared gateway API. But if we are switched to a larger workload at the moment, then we might also have the shared gateway API. It will be having multiple different gateway APIs. Also, the gateway, these particular gateway APIs are being controlled with the help of the kgateway control plane. It's the single kgateway control plane, whether it is in the case of the shared gateway API, or it is the case of the single gateway API. So if it is a shared gateway API, we might be having different gateway APIs, different ingress gateway APIs that are being pushed onto our architecture, but they all will be handled with the help of the same kgateway control plane. And these are particularly helpful if your workload is really large, handling a lot of traffic. It depends upon whether the traffic is huge, it's a lot more bulky, or at the moment it's a lot lesser. It all depends upon the the workload. If it is really large workload, then you might have different gateway APIs that are being pushed, handling different services in your workload depending upon the various different factors as well. Instead of having the shared workload, shared gateway APIs, because it will be exposing the API, the IP address of the gateway, separate gateway APIs to the external world. It might be really dangerous. So instead of that, we might have shared gateway API with a central ingress gateway API. How will it help? Well, it will help you in pushing the shared or the common policies that has to be followed by all the different services in your workflow at the moment. And then later on, it will be connecting the two or even more gateway APIs that are pushed onto your cluster. All of those particular gateway APIs, you might consider them as the child of the central gateway API. If you might have heard about the inheritance and the child or the parent in the the DSN data structures as well. So it is not completely as that, but you might consider as the simple various different policies that were being laid by the central ingress gateway API will be used as an inheritance by the gateway proxies. And if there has to be made any particular change, or if any additional policy has to be laid, then that could be pushed to the separate or the particular gateway API into your architecture at the moment. Let's say we have one of the gateway API, that's the central one, and it is working with the three different the gateway APIs, which will be handling different number of services as well onto your workload. So we might have that this is the first one, second one, and the third one. It will be handling this much traffic. It will be handling this traffic if the the routing policies or the routing the if it is an HTTP request, if it is the TCP or the gRPC, you can split it in this particular manner as well. It all depends upon you. And then later on, if any change has to be made, so then you can also push it and change according to your own will. Instead of gRPC you might have different the routing policies as well, so the rules. So that was all about the shared gateway API, whether it's central ingress gateway API. You might also, if let's say I'm having a particular project and I was having a Selenium ingress gateway API earlier, and I don't want to change that. Instead, I can only manage to push some more gateway APIs and some more gateway APIs instead of just pushing the older one out of the architecture. It would be a lot more tedious according to me. So let's say, so we might have set that particular the older gateway API as the central one, and then it will be handling the child ones, the gateway APIs which were being laid onto your architecture, and those will be handling the traffic that is coming, the incoming traffic to the different services of your cluster. So yeah, that was all about the the shared gateway, simple or the single gateway API, then the shared gateway API, then the shared gateway API with the central ingress gateway API, and the the custom gateway API as well. So if you had it earlier. Alright, so that was all about the kgateway projects, and about about its architecture, as well as about the deployments as well, various different ways in which the gateways can be deployed into our architecture. It has a lot more lesser carbon footprints has been uh, wasted. It reduces the carbon footprints, as well as also it's a lot more inclined towards the sustainability part. It's also this Solid IO's team, the Gateway project that is being maintained by them. They have also worked really close along with the Istio, so that's why they have also contributed a lot to the ambient mesh as well. If you doesn't know about the ambient mesh, if you does know about the service mesh, if you doesn't know about the service mesh, that I have also uh, uploaded a video about the service mesh. You might won't be knowing about the ambient mesh, so I'll make a dedicated video about the ambient mesh in my next video, and use the ambient mesh as well in its whole network policies, the kgateway project. So we'll talk about that as well as also about the MCP adoption as well, MCP servers and various other things as well. It's an amazing project, so we'll try to cover it up in my next lecture. Alright, thanks a lot. Radhe Radhe.